Let's look at a picture of a quadratic function and find the vertex form of the equation for that graph. We're also going to find the domain and range since we have a picture. So let's start with what's review. Domain is reading a graph left to right. Whether you're looking at a quadratic function or not, that's the same. You read left to right. This graph goes out far to the left and far to the right. So in terms of x values, far to the left is negative infinity and far to the right is positive infinity. So our domain is negative infinity to positive infinity. In fact, that's the domain for every quadratic function. The range means reading the graph down to up. What's the furthest down it dips to what's the highest up it goes? These are y values. Normally, when we read graphs in interval notation, we're looking at x values, except for if we're looking for range. So I'm looking for the furthest down that I see the graph go. The furthest down the graph is at the point x is 2, y is negative 3. So we're going to start at the lowest y value is negative 3. We're going to include that because that is a point on the graph. There's not an open circle there. From negative 3 and the highest up it goes, it's going up, up to the left and right. So our highest y value, it's going to continue up to positive infinity. So we're going to use that vertex that we just identified to start writing the equation for this quadratic. So our vertex is 2, negative 3. And so we're going to plug that into our general formula for the vertex form of a quadratic, which is a times x minus h squared, and then we have k on the outside. So x minus h is going to be 2, and then k, the number on the outside, is going to be negative 3. So the only thing left to find in this formula is this a. So we know h and k, we filled those in. And to find a, we just need to pick a random point on the function to plug in here. So I can choose any point. I'm going to choose this one here because it's nice when I can plug in a 0 for one of the letters. So this point is 0, 1, which means that y is 1. We're solving for a, so I'm going to leave it as a. When x is 0, though, so 0 minus 2 squared minus 3. So we know x and y. We already found h and k. And now we just plugged into the point 0, 1 to find a. So 1 equals a times negative 2 squared. Negative 2 squared is 4 minus 3. So I want to get a on one side by itself. So right now we have 4a minus 3. And I want to get the a by itself, so I'm going to add 3 to both sides. So I get 4 equals 4a. I'm a little bit closer to having a by itself, but it's still multiplied with 4. So I'm going to divide both sides by 4. And the value for a is 1 then. So my equation is going to be y equals 1 is my a, times x minus h is going to be x minus 2 squared minus 3. If I'm not sure if I did that correctly, I could plug in other points. Like I could plug in 3 for x into this, and I should get negative 2 out for the y. If I plugged in and I created this formula correctly, if I replace that x with a 3, I would have 1 times 1 squared, which would just be 1, minus 3 would really give me that negative 2 in the y. So you can always plug in a random x and see if you get the correct y out. If you do, then you have the correct formula.